Hello everyone. On this video we will be looking at synthetic division and the remainder theorem. Okay. Now synthetic division can be used as a shortcut for long division of polynomials when your divisor is in the form x minus k. Okay. So let's look at these examples here to give you an idea of when it can and can't be used. Okay, so what if you have 4x to the third plus 2x squared plus 7x plus 4 divided by x minus 2? Yes, it can be used because your divisor is in the form of x minus k, and in this case, k is equal to 2. Okay, what about this one? 5x squared plus 7x plus 8 divided by x plus 4. Yes, you can use it here. Why? Because x plus 4 can be rewritten as x minus negative 4. So in this case, your k would equal negative 4. Okay, so what about this one here? 2x to the fifth minus 4x to the third plus x squared plus 9 divided by x plus 3. Yes, for the same reason as this one, x plus 3, you can rewrite it as x minus negative 3. So in this case, your k would equal negative 3. Okay, what about this one? 7x to the third plus 2x squared plus 5x plus 9 over 3x plus 2. This one you cannot use it because you can do whatever you like, but 3x plus 2 is not in the form x minus k, just because of that coefficient. So to divide this one, you would have to use the long division of dividing polynomials. Okay, so you can only use synthetic division when your divisor is in the x minus k form, or you can write it in the x minus k form. All right. So if you are still writing, feel free to press pause, but we're going to go ahead and move on to our next page, which shows the steps for synthetic division. Okay, so what if you wanted to divide ax to the third power plus bx squared plus cx plus d? For example, you can do from x to the 7th power on down, x to the 20th power. You can do x to the 100th power on down. We're just using this as our general example. Okay, you're going to use the following process. Okay, so it's x minus k. So you're going to write your k value. Then you're going to write what looks like an upside down division bracket. And then all of your coefficients, your a, your b, your c, and your d, you're going to put here. A, b, c, d. Coefficients of our numerator or our dividend. Okay, so the first thing you're going to do is bring down that first coefficient. We'll make that a. Okay, then you're going to multiply k times a, whatever that value happens to be. Then you're going to add these two together. Okay, so let's say you add b plus k times a and you get some value f. You add those two together and you get some number f. Then you're going to multiply k times f, then add them together. Okay, so let's say c plus k times f gives you some number that we'll call g. Okay, so then you're going to go ahead and multiply k times g and add those two together. And let's say you add those two together and you get some value that we'll call r, and that's your remainder. Okay, so this is the process you would use for synthetic division. All right. So if you are still writing, by all means, feel free to press pause. But we're going to go ahead and move on to our first example. Okay, so let's say you wanted to use synthetic division to divide, that E can be a little neater. There we go. To divide x to the fourth power minus 10x squared minus 2x plus 4 by x plus 3. Okay, so there are a few things you always want to look out for. These two things are where most mistakes happen with synthetic division. So you want to be aware of them. Okay, so the first thing is your exponents have to be in descending order. The function has to be in descending order. All right, so that means x to the fourth minus 10x squared minus 2x plus 4, you're going to rewrite it. You're going to rewrite that as x to the fourth power plus 0x to the third power. See, there's no x to the third power here. Minus 10x squared minus 2x plus 4. And it's going to be divided by, you have your x plus 3, so it's going to be x minus negative 3. Okay, and in this case, that means your k is going to equal negative 3. So this is what you're going to use. So this is how it should look after you rewrite your function and your divisor. Okay, so our k is equal to negative 3, so we're going to put our negative 3 right on the outside and then put our upside down bracket here. Okay, so you have 1x to the fourth plus 0x to the third minus 10x squared minus 2x plus 4. Okay, so you just put all of your coefficients there. Okay, so we bring down our first one. Negative 3 times 1 is negative 3. Then we add those two together. Let me clean that up. There we go. Okay, 0 plus negative 3 is negative 3. Negative 3 times negative 3 is positive 9. We go ahead and add those two together. Negative 10 plus 9 is negative 1. Negative 3 times negative 1 is positive 3. Go ahead and add those two together. Negative 2 plus 3 is positive 1. Negative 3 times 1 is negative 3. We add those two together. 4 plus negative 3, positive 1. That's your remainder. Okay, so I'm going to go ahead and show you how we can read this. Okay, so we know here we have 1x to the fourth plus 0x to the third minus 10x squared minus 2x plus 4. So let me clean that 4 up a little bit. There we go. Okay, so what we're going to do now is we're going to lower each of these exponents by 1. Okay, so this will tell us how to read that. So if we start off at x to the fourth, this is 1x to the third, or just x to the third, minus 3x squared, minus 1, with remainder, or plus 1 with remainder of 1. Oh, minus x. Sorry about that. Minus 1x. So that should be, there we go. Knew something didn't look right. All right, so now this is how it would look. So you have x to the fourth minus 10x squared minus 2x plus 4, where x plus 3 will equal x to the third minus 3x squared minus x plus 1 plus your remainder of 1 over x plus 3. All right, so that's how you would solve that one using synthetic division. Okay, so if you are still writing, feel free to press pause, but we're going to go ahead and move on to our next page, which we'll look at the remainder theorem. There we go. Okay, so for your remainder theorem, we know that if a polynomial is divided by x minus k, then the remainder is r equals f of k, or f of k equals r. Okay, so for example, let's say we wanted to use synthetic division and the remainder theorem to evaluate f of x equals 3x to the third plus 8x squared plus 5x minus 7 at x equals negative 2. Okay, so x equals k is just k equals negative 2 in this case. All right, so what I want you to do is I want you to press pause and do the synthetic division part on your own, and I'll show you how to read it after that. All right, so I'm assuming you've pressed pause and worked this one out. So let's go ahead and verify. Okay, so we know that k equals negative 2. So it could say x plus 2 or x minus negative 2. So we know our k is equal to 2. Same thing. Okay, so we put our negative 2. We can look at our exponents first. So either 3, 2, 1, and nothing. So we're good there. We don't have to rewrite it. So you have negative 2. Okay, we have 3x to the third plus 8x squared plus 5x minus 7. Okay, so we go ahead and bring down our first one. Negative 2 times 3 is negative 6. We add them together. 8 plus negative 6, positive 2. Okay, negative 2 times positive 2 is negative 4. We go ahead and add those together. 5 plus negative 4 is positive 1. Negative 2 times 1 is negative 2. We go ahead and add those together, and we get negative 9 as our remainder. All right. So we see here, remember this is, I'll go ahead and rewrite that. Let me clean that up a little bit. There we go. 3x to the third plus 8x squared plus 5x minus 7. So to read that one, it will become, remember that's to the third power, so this one would be 3x squared plus 2x plus 1 with a remainder of negative 9. Okay, so this tells us that 3x to the third plus 8x squared plus 5x minus 7 divided by x minus negative 2. Okay, so I'll put a little x minus negative 2, so you know where that came from, is equal to 3x squared plus 2x plus 1, remainder of negative 9, so it's minus 9 over x plus 2, or x minus negative 2. Okay, so we know how to solve our division of polynomials using synthetic division, so let's look at what this means. By the remainder theorem, which says that f of k equals r, we know that f of negative 2 is equal to negative 9. Okay, how do we know that? Well, we can double check it. Okay, so f of, let's put check right here. So f of negative 2. Okay, so that's going to equal 3 times negative 2 to the third, plus 8 times negative 2 squared, plus 5 times negative 2 minus 7. Okay, so this equals negative 2 to the third is negative 8, so 3 times negative 8, plus negative 2 squared is positive 4, so that's 8 times 4, plus 5 times negative 2 is negative 10, so that's minus 10, minus 7. Okay, so that's going to equal negative 24, plus 32 minus 10 minus 7, which gives us negative 9. Okay, so you can see here, this is a whole lot faster than doing it this way if you had a really large function. So let's say if you had a function to the 7th power or something like that, this would be a whole lot faster. Not this. This would be a whole lot faster than this. All right, so if you are still writing, feel free to press pause. But we're going to go ahead and move on to our next page, which shows us the remainder theorem results. Okay, so your remainder are that you get from synthetic division of some function f of x by x minus k, and I'll just leave k there because we're really using the k value, so this is correct there. Okay, so the remainder r gives the value of f of x at x equals k. So remember, f of k equals your remainder. But if r is equal to 0, then x minus k is a factor of f of x. Okay. Also, if your remainder is 0, then your k value and 0 is your x-intercept for a graph at f of x. Well, for f of x or of f of x. Okay. So this remainder theorem is really helpful. It can cut down on a whole lot of work. Okay. So if you're still writing this, please feel free to press pause because this is very important stuff. So let's go ahead to our last example. Okay. So which function is a rational 0 of 10? Also identify what each remainder means. Okay. So for A, let's say g of x is equal to 2x to the third minus 11x squared plus 18x minus 80. Let's say for B, your g of x is equal to x to the third power minus 11x squared plus 18x minus 60. Say for C, you have g of x, and that will equal x to the third power minus 11x squared plus 18x minus 80. And for D, what if g of x equals 2x to the third minus 11x squared plus 12x minus 60? All right, so what I want you to do is find out which of these functions is a rational 0 at k equals 10, and also tell me what each of those remainders will mean. All right, so go ahead and press pause and try this on your own. All right, so I'm assuming you've pressed pause and worked this one out, so let's go ahead and verify. Okay, so remember, you know that k is equal to 10. Okay, so for a, you have 10, and let's go ahead and drop that down. You have 2x to the third minus 11x squared plus 18x minus 80. Okay, so we bring down our first one. 10 times 2 is 20. Go ahead and add them together. Negative 11 plus 20 is positive 9. 10 times 9 is 90. Go ahead and add them together. You get 108. 10 times 108 is 1080. We add those together and we get 1000. So our remainder equals 1000. Okay, so what does this tell us? Well, it tells us that this g of x does not equal 0 at x equals 10 or k equals 10. Okay, so in other words, g of 10 does not equal 0. Okay, well, what else does it tell us? Well, it also tells us that g of 10 is equal to 1000. Okay, so if you plug 10 into this one, this g of x, you get 1000. Okay, so what about the next g of x? Okay, remember it's at k equals 10. So you have 1x to the third, put the 1, minus 11x squared, plus 18x, minus 60. Okay, so we bring down our first one. Let me move this up a little bit. 10 times 1 is 10. We go ahead and add them together. Negative 11 plus 10 is negative 1. 10 times negative 1 is negative 10. We go ahead and add them together. You didn't need that plus there, but 18 plus negative 10 is positive 8. 10 times 8 is 80. Go ahead and add those together. And we get 20, so our remainder is equal to 20. So what does this tell us? Well, this tells us that for this one, this particular g of 10 does not equal 0. But it also tells us that g of 10 equals 20. So if you plug 10 into this g of x, you'll get 20. Okay, so what about c? Okay, again, our k is equal to 10. You have 1x to the third minus 11x squared plus 18x minus 80. So you have 1x to the third minus 11x squared plus 18x minus 80. Okay, so once again, we bring down our first one. 10 times 1 is 10. We add these two together, and we get negative 1. 10 times negative 1 is negative 10. So we go ahead and add these two together. We get positive 8. 10 times 8 is 80. We add these two together, and we get our remainder of 0. Okay, so what does this tell us? Well, this tells us that x equals 10 is a rational 0 for this g of x. Or in other words, for this one, g of 10 is equal to 0. Okay, so what about the last one? Our k is equal to 10. So we have two, let me move this down a little bit just for a second. 2, negative 11, 12, and negative 60. 2, negative 11, 12, and negative 60. So we bring down our first one. 10 times 2 is 20. Add these two together, and we end up with positive 9. 10 times 9 is 90. Add these together, we get 102. 10 times 102 is 1020. Add these two together, we get 960. Okay, lets us know that for this one, this g of 10 does not equal 0, but it also tells us that g of 10 is equal to 960. Sorry about that. All right, so in situations like this where you have 10s, you could even have a 12 or 15 where k would equal any of those values. If you had to do k equals 15, it would be a lot easier to use synthetic division than to plug in 15 over and over and over again and have to do all that other stuff. So this just makes your job a lot easier and can cut back on a whole lot of time. All right. So hopefully this made sense, and I will see you on the next video.